Alright, today we're going to be talking about vector addition, and we're going to be doing an overview about trigonometry in case you need to brush up on a few of these concepts. Or if you've never encountered them before, I'd recommend you watch this video and follow along, and this should get you through all the math you need for this unit. Alright, so first up, let's talk about what we do when we have to add vectors when they point along the same direction. Now, when this happens, vectors can pretty much be added together like they were numbers. Typically, what we'll do is if a vector points right, we'll give it a positive sign. So here we've got 2 newtons pointing right, so we'll pretty much treat that like a positive 2. We've got a 3 newton vector pointing to the right, positive 3. And that should give us a 5 newton vector that points to the right, or has a positive 5 newton vector. Now, if we were to add these same vectors, but all we were going to do was turn the 2 newton vector around 180 degrees so it points left, what we would do then is treat it like it was a negative 2 newtons. So here we've got negative 2 newtons plus positive 3 newtons. That will give us a smaller vector that's just a 1 newton vector that points to the right. So it turns out that when adding vectors and they are along the same direction, they will add algebraically. Now, when vectors do not point along the same direction and we have to add them together, we have to do some trigonometry. So in this case, what we have are 2 vectors that are at right angles with each other. We've got an 8 newton vector that points right and a 10 newton vector that points upwards. So first up, the resultant, or the sum of the 2 vectors, also called the resultant, looks like that. It goes from the tail of one to the head of the other when you put them from head to tail. Now, these will also obey the rules of trigonometry, which includes the Pythagorean theorem. So in this case, all we need to do is a squared plus b squared equals c squared. And noticing that this basically just makes a right triangle, we've got 8 newtons squared plus 10 newtons squared equals c squared. This gives us 64 plus 100 equals c squared. 164 equals c squared. Taking the square root of both sides and keeping the positive solution, we get 12.8 newtons. So the resultant vector looks like that, 12.8 newtons, and it will point diagonally like that. Now, we can kind of go backwards too. So if we have a diagonal vector, we can break it down into what we call x and y components. So vector components are what you get when you project a diagonal vector onto the x and y axis. So they always make right angles with each other, and they kind of make a right triangle in such a way that the original vector is the hypotenuse. So in this case, the original vector would look like this, and we would have a y component and an x component. Now, vector components and the diagonal vector that they're made of obey the rules of SOHCAHTOA as well, not just the Pythagorean theorem. So if you know these identities, which I will give you on a test or a quiz, you should be able to find anything about a right triangle. It turns out all you really need is a side, any side, and a angle, and you are set for doing this math. So let's do one more example. Okay, so in this problem, we've got a 100 newton vector, and it makes 60 degrees with the horizontal. So we're going to use SOHCAHTOA on this. And let's draw the components here. I've got an x component and y component. I'll do the x like this. And that makes 60 degrees with the horizontal. And the y component will look like this. and the two components make right angles with each other. Notice that altogether 3 make a right triangle. Okay, so if we wanted to do the calculation for the x component, we would first notice that we have the hypotenuse, and we have also got the 60 degrees here, which is enough to give us all the information we need to know about this. So this, the x component that we have, we will call fx, and what we have here is cosine 60 is equal to the adjacent over the hypotenuse. So here, the adjacent is fx, and the hypotenuse is 100 newtons, and that gives us cosine 60. Moving things around, I have that fx is equal to 50 newtons. And that's it. For the y component, what we would do is something similar, though notice that the y component is now the opposite side. It's opposite from the angle that we have. So what we would do then is, instead of using cosine, we would use sine of the angle is equal to the opposite over the hypotenuse. So the opposite is fy. The hypotenuse is something that we have, the 100. That's equal to sine 60. So moving things around, we have fy is equal to 86.6 newtons, and that's our answer for the y component. So if you have any more questions about this, ask me in class.